Well, so we're recording and we're now live on Facebook. So I'm just kind of open up the evening formally and just thank everyone for being here. So this is Husky Bites. Husky Bites is a Michigan Technological University College of Engineering production, and I'm the Dean of the College of Engineering, and my name is Janet Callahan. We have a wonderful International Women's Day lineup today where we have two different speakers who will be introduced soon. And I have co-host with me, Dr. Audra Morse, who is professor and chair of civil environmental here at Michigan Tech. And so I'm going to go ahead and make sure I can share screen, and I'm going to there we go. All right, so as I was saying, this is Husky Bites. This is the third season. The first season was summer, the second season was fall, and now we're in our third season. And I want to just sincerely thank our sponsor this evening, who is Marnie O'Donnell Clute, class of '88 BSCE. I believe everyone in the room, everyone who is here in my room with me on Zoom here knows Marnie. So thank you so much, Marnie. All donations are directed towards student scholarships unless you want them directed toward another person. And we have matching for up to $25,000 of gifts to the Michigan Tech Annual Scholarship Fund through Michael and Karen Gregory. Thank you so much. So if you're interested in giving, you can go to the website shown, which is www.mtu.edu/give now. Or if you can't remember that, or you don't, you just want to get some more directions, you can just drop a quick email to engineering@mtu.edu. And you can give anonymously or non-anonymously, whatever you would like. We are happy to accommodate you. So we're doing something really interesting and special this evening. We, starting today, March 8th, teachers in Michigan are able to earn sketches. All right, and so what's a sketch? It's a state continuing education clock hour. So Michigan teachers are able to earn sketches for attending Husky Bites live on Zoom. So if you know of any teachers who you might want to make sure they know about this, just send them this information of registering for Husky Bites, and then they would get a sketch form. And if anybody has any questions about this, just drop an email to engineering@mtu.edu. So we want to find out if we have any teachers with us this evening. So this is a who is joining us today, and there is a poll that should have just launched if you're watching us on in the Zoom webinar format. And so the questions are: who is joining us today? Are you a Michigan Tech student, a pre-college student? Did you attend Michigan Tech, or an alumna or an alumnus? Are you Michigan Tech faculty and staff? Are you a friend of Michigan Tech? I think I've got a lot of categories now. Are you a family of current or future students, K through 12 teacher, or a curious person? So I don't see any teachers joining us yet. So folks in Michigan, spread the word to your favorite teacher in Michigan to have them join us, because it's part of their professional development, and then they can bring some of these ideas back to class, which would be terrific. So we've already got 65 people who voted, 86 people already in the room, and we're just on the hour now. So I'm going to go ahead and end that poll. And thank you so much. All right, let's see. I believe I mentioned every time we do broadcast this live through Facebook. If you just go to College of Engineering Facebook, that's another way to watch us. We have 6 remaining speakers, and our next one up is focused on the metal that you might find in your own backyard, which is with Tim Isley. And we've got some really interesting topics, including fishing, marine autonomy, a couple on fishing. We've got birds, and we've got an enterprise team featured, and also making it in the new music economy, which will be April 5th. All right, and so this is our speaker next week, Tim Isley from Chemical Engineering. I do hope you'll join us. And at this point, I'm going to stop sharing. And so our first person who's going to speak, why don't you go ahead and start sharing your slides so we can make sure we can hear you. And while you're doing that, I'm going to introduce my co-host this evening. I'm so pleased to introduce Dr. Audra Morse, Chair of the Department of Civil and Environmental Engineering. Dr. Morse is a board-certified environmental engineer. She's also a fellow of the American Society of Civil Engineers. She earned her degrees in environmental engineering and in civil engineering from Texas Tech University, which is where she made a solid start on her professional career and worked as assistant, associate, and full professor, and I believe associate dean, if I have that right. Yes. So Dr. Morse has many different hobbies, including skiing, acrylic painting, spending time with her boys and husband, cooking, walking her dogs, and so much more. And I'm very pleased to have you here co-hosting. I'm going to call you Audra, and I'm going to turn it over to you, Audra, to take it over.
Thanks, Janet, and I'm very excited to be here. I have to secretly confess, I have a little bit of a crush on this bridge. When I moved to Michigan Tech, I came from the West, and I did not have an opportunity to cross over the Mackinac Bridge, so I just didn't feel like this was my new home until I had an opportunity to do that. And in fact, my first journey was with someone who is near and dear to me. You've already been introduced to her tonight, and that was Marnie Clute. And I was very thankful that day because Marnie was driving and she was giving me the stories about the bridge and telling me about the tech history and how connected Michigan Tech and this department is to the bridge. And so after I was like a giddy schoolgirl that day going, I get to go over the bridge. This is so awesome. Well, then I thought, well, how can I be the chair of the Civil and Environmental Engineering Department at Michigan Tech without a picture of the bridge? So I have a picture of the bridge that I keep in my office at all times. It would be bigger, but my office has very little wall space. So this is about as big as I could get and still have a picture of the bridge in my office. So I have maximized that picture. And it is a constant reminder of the special people like Kim and Amy that you're going to hear from tonight. I actually get the honor of introducing two outstanding engineers, two wonderful people, and then two women that I really look up to. And I'm fortunate that my journey to Michigan Tech brought them into my life. So I'd like to share a little bit about them both. Kim graduated in 1985 with her Bachelor of Science in Civil Engineering, and she started her career at MDOT. And through several positions and time had elapsed, in 2002, she was announced as Chief Engineer of the Mackinac Bridge Authority. And then in 2019 was appointed to be the Executive Secretary and CEO of the Mackinac Bridge Authority, which happens to make her the first female in a 60-year-long history. But this won't be the first that I'll mention about Kim tonight. She has been, through her career, has maintained connected to the department and to Michigan Tech, volunteering her time with the Summer Youth Program. She served on the Civil and Environmental Engineering Professional Advisory Committee, and then was inducted into the Civil and Environmental Engineering Department Academy in 2017. And that was my first opportunity to meet Kim. But it was actually attending the CTT Bridge Conference that I really understood more about Kim. And I remember that she got up and she spoke, and everyone in the room wanted to hear what Kim had to say. And the respect in that room for Kim was so awe-inspiring. And that connects to her more recent award, which was announced March 1st, and that she received the Felix A. Anderson Image Award from the American Council of Engineering Companies of Michigan. And again, first woman to receive this award. And a quote about her is that she has been an inspiration to me personally as a fellow civil engineer and to so many others in the industry. And the Mackinac Bridge Authority is proud of Kim and her contributions. And so the person who was quoted as saying that about Kim was Amy. And so what's really special about tonight is these two engineers' connections to the Mackinac Bridge. So let me share with you a little bit about Amy, and then they'll tell you more, and it's really why you're here. I get it. So Amy is a 1994 graduate of the Bachelor of Science in Civil Engineering program at Michigan Tech. And in 2000, she founded Great Lakes Engineering Group. Many of you may know of Amy because she's very active professionally in Michigan, ACEC, MIDA, ASCE, and in 2019, she was awarded the ASCE Outstanding Civil Engineer of the Year for Michigan. And then in 2019, she was appointed by Governor Whitmer as to the Mackinac Bridge Authority. But what you may or may not know is that in addition to her work and impact that she has professionally to all of us as civil engineers, she's also serving her second term for the Michigan Department of Education Special Education Advisory Committee. And so tonight we have two amazing engineers and women sharing something with us about the Mackinac Bridge, an icon, I think, for the state of Michigan. So I'm going to turn it over to you two. Thank you for being with us tonight.
You're welcome. I'm going to start out the presentation today. Amy and I are doing a little tag team here. And before we leave this first slide here, I'd just like to point out the pictures I chose that were pictures of the parts of the bridge that are going to be doing the heavy lifting. So we're going to look at the foundations. Amy's going to tell us about the foundations that are holding up all the piers of the bridge. And then the top picture there shows the main cable system that you can see clearly in this picture is holding up the roadway. So we're going to talk about those parts that are doing all the heavy lifting. And I'm really happy to be doing something for Michigan Tech. I have my my tech gear on today. Go Huskies. So it's always fun to come back to tech. So before we get too far along, if I was standing in front of you, I would ask how many of you have been to the Mackinac Bridge. So I have a poll question for you. And I'm always interested to see that even in Michigan, some longtime Michiganders have never been to the Mackinac Bridge. And so I usually find a few that have not. So it looks like most everybody has, but just 4% of you have not been to the Mackinac Bridge. So that's great. You need to come up there, whoever you 4% are. 3 of you need to come on up to the Mackinac Bridge. All right. Thank you for that. I'll show you how the main cable system is constructed there. This is a cross-sectional picture of the main cable. And you can see that it is made of thousands of parallel wires that are put into bundles and then squeezed into a circular shape. So this shows how those bundles were made, and then it was squeezed into a uniform circular shape. So there's 12,580 parallel wires in the main cable that are doing all that heavy lifting of the roadway. Before they built the main cable, they had to construct a work platform. So here are the bridge ironworkers getting ready to build that platform system. And you can see in that upper picture, they're stretching that chain link fence out to reach the other part of the chain link fence. And that's going to be what they're walking on while they're building that main cable. So very dangerous job. We're looking out from one side of the cable system through this picture here over to Mackinac Island. There's what we see. So kind of a dangerous job. And then the other picture shows it already in position, and they're using it. They're walking on the chain link fence. They have some railing erected, trusses side to side, so it helps with swaying, and so they could get from one side to the other without going up and down on the tower. So that's the work platform, getting ready to do the work of spinning the main cable. And so they called it spinning because of that spinning wheel you see in that left-hand picture. Even though there is no twisting or turning, it's all parallel wires that were delivered back and forth with that spinning wheel from each anchor pier to the other anchor pier. It was a 24-hour operation going all through the day and night, delivering pieces of wire there. And so you can see this gentleman here, he's reaching up to grab that piece of wire that's going past his workstation, and he's going to bring it down into the slots there and start forming the bundles. As you can see in this other picture here, the bundles that were then squeezed together to form the uniform cable. And that's what's happening in this picture here. In the upper right there, the gentlemen are working on compacting that cable from the bundles into the circular shape. So they're measuring the diameter, and then that custom-made compression machine is squeezing it into a circular shape. I'd like to point out in this picture the lack of safety gear you see in the harnesses, no harnesses or positioning belts or climbing belts or anything. And they're up near the tower top, and that was perfectly legal. That was the rules of the day, and they could work like that, and they most often did. The other picture that is taken in color shows the wrapping wire going on. And you can see behind the men working there, the silver is the wrapping wire that's already been placed on the main cable by this wrapping machine. You see the spools of wire on there. And so that machine made the wire go round and round the main cable. And the interesting thing about this colored picture is the orange color. That was true to what was happening at that time. And that was because those men were placing a paste on the main cable that had lead in it. And so that lead paste that was about as thick as peanut butter was smeared onto the main cable. And then that wrapping wire went on with tension and caused the lead to force itself into the cracks and crevices. And that protected the wires from getting corroded. And so it did a wonderful job of protecting the bridge from rust. But as you can see from those men that are in their blue coveralls that are all orange, they were basically swimming in that lead paste. So there's another thing that was perfectly legal at the time. For safety requirements, nobody really knew about the hazards of lead. So you can see how safety rules have changed a lot in those years. Here's another poll question talking about who designed the Mackinac Bridge. We have three choices there. We have John Roebling and Othmar Ammann, and we have David Steinman. And so we'll see what you think about who designed the Mackinac Bridge. And I'll just let you know that these folks were rock stars of their time period. Bridge designers got a lot of credit and a lot of notoriety for seeing who could build the longest bridge over the deepest water and deepest ravines and whatnot. So, and have them be still standing. So I see David Steinman is in the lead here by quite a bit. And so that would be correct. David Steinman was the designer of the Mackinac Bridge. And those of you that are joining us that are already graduated and perhaps have professional engineering licenses, put a PE after your name. You'll be interested to know that David Steinman was instrumental in causing that to happen. He was a firm proponent of licensing for civil engineers in general, and he was the first president of the National Society of Professional Engineers. And so we owe our professional engineering license in part to David Steinman. So in order to keep the main cable and the suspension system in good condition, we have to do inspections. And so it's a federally required inspection that we do where we test random areas of the main cable. We have to actually open it up and see what's going on the inside. We look at the outside every year, but we have to look at the inside. So we follow this NCHRP report to give us the guidelines for doing the cable inspection. And what we're looking for basically is the stages of corrosion that the wires might be exhibiting in there. So you see the 4 different stages of corrosion that we're looking for when we open it up. And so we have to get our access together before we can even open it up. And so that in some cases can be quite elaborate, as you can see from this high up location that was chosen. It takes a lot of effort, and those are our workers, our Bridge Authority workers that can construct that scaffolding and get the workers up high so that they can start opening up the cable. So we have to take that wrapping wire off of there, and that's what they're doing in the other picture here. They've soldered some pieces together so it doesn't just uncoil on them, and they're starting to take the wrapping wire off, and there is that orange paste right underneath there, right where we left it 60 some years ago. So once we get it unwrapped, we have to look to the very center of the main cable. That's part of the requirements. And so that's what these gentlemen in the lower right are doing. They drive wedges into the cable so that they can carefully crack it open and look all the way to the center of each of the radial positions around the circumference there. So you can see in the bottom picture, there's that orange lead, but now you see that the workers are actually wearing respirators so they don't accidentally breathe any of that in or ingest any of that. And you can see all this climbing gear that they use so that they can be safe while they're doing that inspection. So it's wedged open. This is typically what we see inside there, nice bright shiny wires. a little bit of corrosion on the very outer wires, but all in all, we've always see very good results inside. And then we have to put it back together the same way they did 60 some years ago. So on the left is our workers. They're using a customized compaction machine to put it back into a circular shape after we have wedged it open. You can see all the safety gear contrasting with how they put it together originally, all the climbing harnesses and hard hats, earmuffs, safety gear, shoes, everything. And then we put wrapping wire back on, and we may want to use the lead paste because it does such a good job, but for environment and health hazards, we don't want to use it. So we use a paste now that has zinc in it. So that does the same thing that the lead did in the corrosion process, and keeps the main wires from corroding, because those are the ones that are doing all the heavy lifting. So we wrap it with the zinc paste on there, and then we put a coating on the outside, a flexible paint coating to keep it safe and waterproof. So the result of the inspection, we get drawings like this and analysis like this. It shows a cross-section of where they opened it and the different sectors that they looked at. And they, as I said, they label each wire and give it a corrosion rating. And so you can see, for example, the lower parts have the most corrosion, but still it's just stage 3 down there, a tiny bit of it. Most of it is, I'm not sure if it shows up on your screen, but stage 1 are like new. So very good reports on our main cable inspections. And then this is a different way of looking at it. You have each of the rings of the bridge, of the cable laid out there, and the different levels of corrosion are shown in there so that they can take that and they can do a lot of mathematical gymnastics there in order to get the results that show, along with some wire testing. I didn't mention the wire testing. They actually take out a piece of wire from the main cable so that they can test what the actual tensile strength is at the time. And so using those numbers, and they end up with results that typically show that our cable strength exceeds the design cable strength. And so we have been very happy with our results from the main cable inspections. We'll have some more coming up in future years as federal guidelines change and as we need to keep up with those inspections. So I usually can, this talk about main cable and inspection can take an hour, but I crammed it down into my 10-minute allotment here. So if you have any questions, we'll be sure to look for those. So I'm going to quit sharing now and pass it off to Amy.
All right, hold on. Get down here. All right, thank you, Kim. I'm just so excited to be able to present with Kim. You know, I've got literally a Wonder Woman poster, and I got the Kim Nowack superhero poster. She's just been such a role model for me as a woman civil engineer, and I'm just super grateful anytime I get to spend time with her. So thanks, Kim. It's always such a hard act to follow. How come I always have to present after you? Do a great job. First of all, I just want to say, again, my name is Amy, and I perform bridge safety inspections to ensure the safety of the public. So, you know, you should never question the safety of a bridge when you cross it, including the Mackinac Bridge. You know, it's inspected routinely, both above and below water, by qualified civil engineers and qualified divers. So let's dive right into a very critical component of the Mackinac Bridge, and that's the foundation. You know, many people never even think about the piers when they drive over a bridge, with the exception of the tower piers. You know, the rest of the piers are out of sight. If, however, you've been lucky enough to travel to Mackinac Island by ferry, you can take a look to your left or your right and see the elevation of the bridge and all the quantity of the piers that actually support the Mackinac Bridge. Specifically, there's 33 water piers, 30 of which were built in open cofferdams, and 3 were built in dredged caissons. So this black and white slide shows the beginning of construction, and it all starts with the bottom and goes up, right? So foundation started in the spring of 1954. And of the 33 piers, the most recognizable and definitely the most photogenic piers are the two tower piers. And that's what I'm going to talk a little bit about this evening. The tower piers soar to a height of 550 feet above the water surface, and they plunge down below at least 140 feet to the strait's bottom. This slide gives you a bird's eye view looking down on the top of the tower pier columns. You can see the red outline identifies the massive caisson that supports the columns. The diameter of this caisson is 116 feet. To give you another perspective of the sheer magnitude of these caissons, this slide shows workers in the yard assembling the double-walled cylinders that make up the caisson. So this particular section, let me see, I think the mouse showing up there. So this angled inside section, sharp, it's designed to dig and anchor into the bedrock at the base, kind of like a giant cookie cutter. It's the bottom cutting ring, and then additional caisson rings were placed one on top of another. Up to 8 rings were comprised of a caisson, one caisson. So you can just see, here's these guys, they're, the relative scale of it. Here's another picture showing the double-walled steel caissons after they were floated into place at one of the piers. There's airspace between, you can see these two gentlemen up top here. There's airspace between these two cylinders, and that void was intentional to allow for the caisson rings to float until they were ready to sink in place. Yeah, you can actually see on here the writing ring 8. So the 8th ring at 20, so that's Pier 20, which is the tower pier just on the north side of the bridge. So this slide shows an aerial view of the overall construction of the caisson at the bridge site. The caissons were actually assembled near Alpena on site and barged to the actual construction site. They were lowered into the straight section by section and welded together. The inside of the caisson here was then dredged in preparation for the placement of the construction materials, such as the aggregate and the grout. The aggregates were actually just up the St. Mary's River. They came in from Drummond Island, and they were crushed and screened and washed several times to remove all the fine dust particles. They were shipped here, barged here on self-unloading boats to be placed inside the caissons. Prior to dumping the aggregates, there were vertical grout pipes installed from the surface all the way down to the bottom. After the aggregate was placed in lifts around 10 feet deep, the grout was pumped in down the pipes, forcing water out of the aggregates, turning the material into concrete. The grout pipes were then pulled up and more aggregate was added, and the process continued until the foundation reached the surface. Okay, so I love this picture, even though Kim's gonna like the piers, this was before they were recently painted. So the tower piers look a little bit snazzier now. But history recalls, so many tremendous obstacles, doubts that a bridge could ever be built over the Mackinac Straits. They're a 5-mile stretch of turbulent water that connects 2 of our Great Lakes and separate 2 parts of Michigan. Thought to be impossible due to the underwater terrain, the currents, the high winds, the harsh winters, and the ice. So this slide really shows those extremes, most prevalent to ice. And as the poll question indicated, Dr. Steinman, who was the chief design engineer for the bridge, along with W.O. Fremont, who I believe I think he worked for the Department of Transportation. They made several design assumptions to account for this ice action or ice pressure on the field on these piers. So for the design, they assumed an ice pressure 5 times greater than the maximum that's ever been recorded. The bottom of the foundation is designed to support the bridge and resist the ice pressure. The part that protrudes above the water is minimized, that section's minimized to reduce the surface area that the ice can act upon. Okay, so I know what you guys are thinking. Speaking of ice, this slide, it's Winter Carnival 1954, right? I see, is that, let's see, this guy, is that Marty Gamble up there? And maybe, let's see, maybe we got O'Donnell right there, like Ryan O'Donnell. Let's see, Bruce, no, they're way too young. But anyways, this is just a scene of what the winter shutdown looked like. This is the cofferdam section at one of the other piers, you know, stopped construction. And these guys were able to access it, you know, with the thick ice that covered the straits there. And, you know, the only thing missing here, I think this guy's reading a book. I don't see a cooler, but I'm guessing with that kind of ice, you probably don't need a cooler. So anyways, very, very extreme conditions. So talking a little bit about the underwater construction, you know, these underwater construction methods were a critical component of building the bridge, especially considering the harsh environments and the depths of the water across the straits. Divers were used to do so many different things, from bolting steel cofferdam frames together. They welded those caisson sections together, verified placement of materials. They placed those, you know, grout pipes, just so many things that are difficult enough to do and perform on level ground, you know, only made more challenging by doing it underwater. So for all of these, you know, engineering feats that were achieved while constructing the Mackinac Bridge, there were unfortunate tragedies that occurred. 5 workers died during the construction of the Mackinac Bridge. And the diver in this slide right here is diver Frank Pepper. You know, he ascended too quickly from a depth of 140 feet. And despite being rushed to a decompression chamber, the 46-year-old died from decompression sickness. So in the diving world, it's called the bends. Again, just so many inherent safety risks when diving is involved for work. Okay, here's the trivia, the poll time. What is the most common cause of bridge failure? A, poor construction. B, scour. C, age. D, steel fatigue. Oh boy, it's all over. That's okay, because after this, everyone's going to know the answer. Okay, it looks like steel fatigue is coming in strong at 46%, which is, you know, probably the first thing people think about I-35. There's a lot of different steel structures that have failed, but the answer for our poll here, yep, steel fatigue. Okay, the answer is actually scour. So highway bridge failures caused by scour and stream instability account for most bridge failures in the United States. So what is scour? Simply put, in engineering terms, it's when erosion of soil or streambed material around a foundation is removed. So, you know, when fast moving current comes around a bridge pier, the sediment from around the foundation leaves behind these huge scour holes. And those holes can turn, you know, huge and deep and undermining the integrity of the foundation. So one of the more well-known examples of failure due to scour is the bridge collapse of I-90 over the Schoharie Creek in New York, and 10 people lost their lives in that collapse. So this is very depressing. I swear I'll uplift it a little bit. I'm not sure. There we go. Okay, here we go. So getting into the underwater inspection. Again, earlier I mentioned, you know, I inspect bridges for safety, and that includes the structural elements of a bridge above the water and below, sometimes even 140 feet below. So this slide here shows our dive team preparing for the underwater inspection of the Mackinac Bridge. It took our team 3 weeks to perform the inspection of the 33 water piers. And, you know, those inherent risks that I talked about for diving for work are mitigated by having strict safety standards that are documented and followed by all. So detailed preparation that plans for the worst case scenario is critical. A typical dive team consists of a 3 to 4 person team, a dive team leader, a diver, a backup diver, and a tender. In the first couple pictures here on the top and the bottom left, shows blue skies, sunshine, relatively calm waters. I remember this day because this was one of the anchor piers, and we had just dove several piers, and we stopped there and had lunch. It was just a peaceful day. And then you have the picture on the bottom right, which shows probably the majority of the days we were out there. A little bit more foul weather, gray skies, rain, the waves were kicking up about 3 feet. So, the most comfortable person, no matter what the weather, is the diver who's in the water. They're always donned with the appropriate wetsuit or dry suit to keep them warm and toasty. So the next couple of slides are an attempt to take you down below the water surface and experience the view. We were able to obtain some really good pictures and video due to the awesome visibility of the straits and the low turbidity of the water. So, typically we're diving rivers or other areas that don't have visibility more than 3 feet. And here we had up to 50 feet of visibility. So you can just see how clear it is. And here, this is the steel sheeting that comprised of one of the cofferdams. And you can see how they cut off the material here and the outline of the concrete. Let's see. The next slide here shows, again, I wish we could have gotten back to get an overall picture to see things, but you can see again the steel sheeting for the cofferdam. Here you can start to see some of that aggregate, that Drummond Island aggregate, the top surface of the foundation. This diver here is probably around 20 to 30 feet below. And if you notice this nice clean surface, right, we're able to see so well without having any algae here or growth or zebra mussels. And the reason is that current we talked about. The current is very strong for about the first 20 feet. And then, believe it or not, when you get below that, it really dissipates. And then that's when you start seeing the algae growth. So up top, too fast and swift for those things to anchor on. But down below, that's when we start scraping to see the condition of the material underneath. The picture on the right just shows the remnants of some of the construction methods here. That's a steel H-tile protruding from the top of the cofferdam there, cut off and left in place. The picture to the top right here, this shows just the more steel framework that is resting on the bottom of the straits, leaning against the cofferdam. You do start to see some of the algae forming here. And then this top left picture, the left picture, it's really hard to tell, but this little black blurb over there, this is basically the divers inspecting the top portion of the cofferdam. And that's our dive boat. That's our 23-foot dive safety boat. And it just looks like this little baby beacon way out there. But we do have two-way communication. So there's a transducer that we throw into the water. It rests about 10 feet below water. And that allows the two-way communication between the diver below and the dive team leader up on the boat. It's a great way to instantly convey findings and observations, as well as provide, some safety protocols for the diver in the water. If they had an equipment issue, to call in the backup diver for assistance, those types of things. So you don't feel alone when you're down there. You've got a team up on board supporting you. And then the bottom two pictures, those are two of the divers for the Mackinac Bridge. And the one on the bottom right is me. And just honestly, all of us felt so grateful to be able to inspect this icon. It's really hard to call it work, especially with the visibility, being able to work for Kim, the chief engineer at the time, and Julie Neff, also a tech grad. It was just a truly defining moment in my career and brought me full circle, because this was the bridge that inspired me to become a civil engineer. So, I feel like a little emotional because it just was such a profound moment for me, and so lucky. So before I get the tissue box out, what MTU faculty member worked on the Mackinac Bridge? So this is another polling question. Kim, I hope you're not doing any of these because you probably know every answer. Come on, Audra.
So there's
That wasn't a hint.
there's 4 choices: Audra Morse,
Oh, I'm sorry.
Bogue Sandberg, William Bullitt, or Edward Haltenhoff.
And if it's not too late, you can change your answer. I'm an environmental engineer, and so I'm much more comfortable with the orange lead-based paint side of this, not the actual structure side. So not too late.
Oh, thank you, Janet. I kind of missed that poll. Anyway, so we'll close this out now. We've got the correct answer. Sorry, Audra. Maybe next time. But it is. It's Ed Haltenhoff. So Ed, he was appointed the project engineer for the overall on-site construction of specifically the foundations for the Mackinac Bridge. And then in the mid-50s, he joined the Mackinac Bridge Authority as the chief engineer. And he remained there for probably 10 years. And then in 1980, he actually joined the civil engineering department of Michigan Tech. He received tremendous honors there, distinguished teaching awards, so many things. And, I was, again, fortunate to be touched one more time by somebody who touched this bridge in such a profound way. I had Mr. Haltenhoff as a professor, instructor there during my studies at Michigan Tech. And, his ability to bring the real world into the classroom and his insights regarding the practice of civil engineering was truly impactful. So he's unfortunately no longer with us, but what another icon, just such a tremendous civil engineer. So I'm going to close this out. And I think that was it. I wanted to take the opportunity to say thank you all for your time. It's the most precious resource we all have. So thank you for spending the time with us, and thank you to our sponsor, Marnie. And then with that, Janet or Audra.
Thank you, Kim and Amy, so much for your time and for sharing a bit of history about the bridge with us, but also the civil engineering side of where it is today. I've been monitoring the Q&A. So for those of you who have questions, please type them in and then we'll work through them for the next little bit. But I'm going to back up. I will note that Don Hopper, he noted in the question and answer space that his father worked on the bridge. And so thanks for joining us tonight, Don. All right, so Harry Jones asked, how often are the cables inspected? Is this a function of materials, tension, and covering?
No, it's not a function of those things. It's a function of the age and what you found on each inspection. So if you have bad inspection reports, they want you to do more inspection and more frequently and open up more areas. So it's a function of the age of your bridge and what you have found. So, and it, as I said, it's only the 40-foot section, random sections. And I think we've opened 19 or 20 sections so far. Yeah.
So that connects to Margaret Landsberger's question. She noted that in the circular drawing of the cables, the corrosion seemed to be on one side more than the other, or the bottom, as you pointed out. Why is that?
It's not typical to all the sections that we find. And so that was just that one particular section. And the one thing that is typical is that very bottom of the circular shape, where the water goes down and runs along the bottom of that cable. That is an area we do find more corrosion. So that would be more typical. That one on the side, we couldn't find a correlation with other sections that we had opened. So perhaps I should have chosen a different cross section to show you, so these keen engineers wouldn't have picked up on that.
Well, that's great. That means they were captivated by the presentation.
That's right.
So Walter asked, well, what happens if you find a bad cable? How do you repair it?
Well, and that does happen in other bridges. We have never found any broken cables or broken wires in our inspection, but some other bridges do find broken wires. And so that's another thing that you chart, and it affects your strength of your main cable. But there's ways to splice in a new piece of wire. And so that's what you would do also when you take out a section to test, then you splice in a new piece of wire.
So based on, so the bridge is 60 plus years old, right? So I'm 70 years old, really. So how long will these cables last, Kim?
Well, you know, that's a good question. And the people ask that usually at every presentation I have. And I always say that, you know, there's parts of the bridge that are 60 some years old and parts that are just a few months old from something we replaced at the end of last summer. And so we use all our toll money for maintenance. And as long as we can keep up our maintenance funding and keep up our staffing to do those projects, we can keep after those things that need to be fixed well into the future. And we have good capacity with our roadway. We're not hurting there. And one thing I will say, as the good inspection reports we get on the main cable mean, it was put together well when those men were up there at the tower top without their harnesses doing the construction, and they used good materials. And then since that time, we've been concentrating on keeping the water out of the main cable. We use some innovative paint products. We are always working on the main cable. So it's been well cared for over the years. And if we can maintain that, it'll go well into the future.
All right, so how many days a year, and this is not fair, Marnie. She asked, what is the average number of closure days per year for work to be done on the bridge?
Closure days. Well, some years we don't have any. In some years, like a couple of years ago, we had a couple of ice storms that caused us to be closed for longer periods of time. So I don't even know how that average would work out. But like I said, some years we don't have any full closures at all. So
it seems like I remember my husband went snowmobiling up at Drummond Island, and it was like the one time they closed the bridge, right? I'm like, no way. And I know there's a camera. I'm going to go look. But I think that was maybe it was for the storm, but it was high winds, right?
Well, high winds and blowing snow will also close the bridge because it's zero visibility on the causeway and people smash into each other.
Yeah, I thought it was just a convenient excuse to not come home after a long weekend, but
you can always call me, Amy. I'll tell you.
Cold busted.
So we're a bunch of curious people, Amy, about your diving career. You know, what got you started in it, and maybe you could tell a little bit about starting your business.
Sure. Well, I guess the business part I'll start first because I've just always had a passion for bridges, and inspecting bridges, kind of giving them a physical understanding, the areas that are deteriorated and what can be done to fix them to kind of bring them back to capacity, and that curiosity about what happens below the water was just gnawing at me. So after, inspecting bridges for about a decade, I'm like, darn it, I got to figure this out. So, of course, high risk type niche thing. A lot of training went into that, and a lot of resources for the proper safety equipment. And, started just doing these dive inspections for a lot of local road commissions, to get the experience in order to become pre-qualified to do them on MDOT structures. And, it's just that curiosity really that, what's going on down there? I can probe and I can be in my kayak or my boat and kind of see, but you can't see the structural integrity of something, looking down the water or even feeling it with a probing rod. And heaven forbid, that number one cause for bridge failure is scour. So we really want to get our arms around what that is at each bridge that we inspect. So that was part of it. And as far as the diving career, I think we started around 2000, right when the economy tanked. We were fortunate enough to start kind of leaning on the underwater work that we do. That's really, really thrived. And I think now, getting more senior in my career, 27 years experience, I guess that's senior, but I'm more of the country club diver now in the company. where the good visibility is really important for me. And, you know, we've just got an amazing team of qualified divers that absolutely love what they do. And, you know, safety is number one.
Well, all right. So this is a curious person asking, how many vehicles have blown off the bridge? Is this a myth, or is this a goose
Well,
egg?
you know what, that is a big goose egg, that none of them have actually blown off the bridge. In '89, there was a Yugo, if you remember what the Yugos look like, and
Yeah.
and how small they were. Anyways, Leslie Ann Pluhar was driving across the bridge and got out of control on this October night. And she veered onto the center mall, off the center mall, onto the center mall. And she hit the railing perpendicular, and they estimated she could have been going up to 65 miles an hour. And so she did go over the edge, but the law, the court cases attributed it to driver error. So that was a sad case, and not attributed to the wind. And then there was another Bronco that went over the edge, and that was attributed to a suicide. There was not any wind related or anything like that. So 2 sad cases in the bridge history.
I am glad that you debunked that, Kim, because when you Google Mackinac Bridge, that is a question that comes up. So
Yeah, why is that?
from you.
I don't know why.
Yeah, no.
Well, I think there's a phobia a lot of people have crossing a bridge, especially a structure as long and as tall as the Mackinac Bridge. So people are just looking, you know, want to make sure it's safe.
Yes, and it is. Mhm.
Well, and this is just a quick, just fact check. What year and maybe month was the bridge completed and commissioned?
Jim, do you want to take that?
They opened November of 57. So yeah.
Just in time for winter.
Yeah, that's right.
There was someone who said that they played in the Sioux band performed at the dedication. So someone listening tonight was in this high school band.
Wonderful.
Attended Michigan Tech and graduated. There's 2 people, one in 61 and 63 with a Bachelor of Science in Mechanical Engineering.
Wonderful.
That's awesome.
Yeah.
So there's a question, and I think it has a technical answer, and it's about the bridge itself, and why is there a solid surface on the outside lane? And they want to know, would it be easier to get across on a motorcycle if the bridge was surfaced so that the inside lane, I guess, was surfaced instead of graded for folks with height fears? So why the outside lane is surfaced instead of the inside lane?
Well, the majority of the traffic stays on the outside lanes. And so the solid surface is put on the outside lanes so that they're able to drive on the solid surface. And so the inside lanes have the grading to allow for the air movement. And it's a really lightweight part of the bridge. Strong, it holds a lot of live load, but it's a lightweight dead load. So changing it around, you'd be forcing most of the traffic to drive on the grading if you put the grading in the outside lanes. So we are looking right now, we're doing a deck study and looking at all different ways to keep the airflow yet keep the solid surface. So we do get questions from motorcycles that don't like to drive on the grading, but we have never had any accidents from a motorcycle driving on the grading. So it's just an uncomfortable feeling instead of an actual safety hazard.
Well, and that makes sense. You're taught to, drive on the right side unless you're going to pass. That's when you enter the left lane and then pass. So yeah, no, that makes really good sense.
Mm-hmm.
I've been keeping up with the questions, kind of writing down when they're done. We still have 32 open questions. So Audra, keep going.
All right. So I guess, the airflow, let's talk about that, because one of our listeners tonight and participants asked if anything like Tacoma Narrows happened to the bridge, but that would be the importance of the grading on the bridge deck.
Yeah, the importance of the grading. And in fact, in my bigger shows, I do quite a comparison with Tacoma Narrows and the Mackinac Bridge. And even in the picture behind me, you can see the structure under the, well, you can't see the suspended span from the picture behind me, but it's very similar. The truss underneath the roadway that adds stability and keeps the bridge from twisting. In Tacoma, they didn't have that deep truss. They had 8-foot solid steel girders on the sides of the Tacoma Bridge and a full solid deck. And so that was just like a ribbon twisting and turning. And, you know, I give David Steinman a ton of credit because everybody saw Tacoma Narrows fall into the river. And there he was saying, well, I can build a bridge across Mackinac Straits, and yeah, it'll be bigger, it'll be taller, and they have more wind, but I can do it. So he was quite bold, and he proved it all with his reports. And we get excellent testing when we're doing some wind tunnel testing right now for our deck study, and get excellent reports on our existing configuration. So it's very see-through as far as the wind goes.
So related to that, and then maybe we'll change to a couple other topics, but what is, say, the sway the bridge experiences during a significant wind event?
Well, it doesn't really sway. It moves to the side. It's made to move to the side from the pressure of the wind. And so it will move out if the wind, our engineers tell us, if we had 100-mile-an-hour sustained wind, it would move out 25 feet at center span, east to west. So, and then it comes back when the wind subsides, it comes back and settles back into its central position, but it doesn't swing side to side.
Okay. So we have a few questions related. I feel comfortable, a little more comfortable with them because they're related to the chemistry. And so if the Great Lakes were saltwater, what criteria, how does the criteria change for, say, inspection, or how does that impact the bridge operation?
Well, I'll just
go ahead, Kim. You want to talk about the salt not being up top, but it's the salt water specifically, right? You know, having a little bit more degradation and reaction to anything steel or metal below. You know, like I said, the aquatic environment and the marine environment is completely different than it would be if it were saltwater. Is you know, as far as things that can deteriorate and eat away at the bridge foundation.
So in the pictures you showed, Amy, what would you have expected after, say, 60 years?
A lot of deterioration, probably holes in the steel sheeting section, section loss itself. You can see probably corrosion and, you know, the leaching and the reaction occurring even underwater.
There's also salt fog too that occurs over saltwater bodies of water, and so I would expect deterioration of the steel to be affected too. Absolutely.
So then, go ahead.
Well, here's another chemistry question from Terry. I might have missed it. Are sacrificial anodes used?
It's a great question about any substructure repairs to date. I don't think the anodes have been used. Maybe in the deck patches up top, Kim?
Yes, we are using them in some of the bigger deck patches up top, and we use them on our pier repairs too, and that have been done within the last 10 or 15 years. So, but yeah, they weren't around back then, but we are using them where they're appropriate right now.
Well, in the actual packing of the lead and then the zinc around the wires is another form of sacrificial anode, I believe.
Yeah, right, for sure.
So what is the original design life of the bridge? Do you know?
Lifetime, you mean?
Yeah. Because normally we, as civil engineers, we design things for a certain life before, you know, being decommissioned or replaced. And so what was the bridge?
You know, I'm not sure. I think I've read David Simon saying 100 years, but I don't know if he knew exactly what kind of maintenance the bridge would get or anything like that. So, you know, it's all dependent on how you keep it up, you know, really. So.
And Kim, I mean, the Mackinac Bridge Authority, the maintenance staff there has done a tremendous job. maintaining this bridge, and it shows with all the safety inspections and detailed inspections, and even everything comes back that this is just truly a gem and a standard to be held to, and it's a lot attributable to the maintenance forces out there.
Mhm.
So Amy, question for you. Are robots drones? Do you use them when you inspect bridges?
You know what? We do have a couple drone pilots, and we have been able to access areas that are difficult to reach otherwise. So yes, we do. And we also have, it's called the Emily, and it's basically a powered boat that is able to retrieve a diver in very swift currents or drag a driver to an area. It also is outfitted with down scan and side scan sonar, so we can get some imagery before we do a dive to kind of prepare for it, for the safety. A lot of debris that we find when we do underwater inspections, so to identify the locations of those, prevent some snag opportunities for a diver. So as far as anything else with the drones, I definitely think they have their place.
Mm-hmm. And so you use drones in the water. Do you use drones for like aerial inspections so you don't have to climb?
We do, just basically as like a cursory review. A lot of the work we do is hands-on inspection. So we will do whatever it takes to try to find the access. But sometimes this is a great preliminary look to say, is that just paint peeling on that steel beam, or is that some corrosion? Do we need to go through these efforts to get the access, the reach all equipment? We do a lot of technical rope access too, as far as getting to difficult to reach areas. So again, it's a great first line defense, but until the regulations change, that hands-on inspection can be, definitely augmented with the drone in those images. We'll continue to use both.
Oh, that makes good sense. Really good sense.
So a comment from Michael, who was a Cub Scout who rode in one of the Oldsmobiles used for each county at the bridge dedication.
Oh, neat.
Yeah, that's a great memory.
Yeah. We replicated that for the 50th anniversary. We got all kinds of convertibles to come across the bridge to try to replicate that parade of Oldsmobiles.
Oh,
So
Kim, there's a good one. Hold on. Who's the most famous person who visited the top of a tower? Depends on who you ask.
Yeah, right. Depends on who you ask. Yeah.
Oh,
I don't know.
anyone like Frank Sinatra or something like that, or no?
Miss Michigan goes every year, pretty much. There's been a lot.
That's a fun one.
Mike Rowe, he's a pretty famous guy, right? From Dirty Jobs.
Yeah, Dirty Jobs, absolutely.
So there's a bunch of people who want to know what your second favorite bridge is. So I don't know. Do you have a second favorite
I can't
bridge?
see my screen here of what I'm showing, but this one over here is the Houghton Hancock lift bridge and the portage. It's a night shot, so it's a little bit hard to see, but that is absolutely a wonderful structure too. The only lift bridge we have here in the state of Michigan, and an icon for Michigan Tech, connecting people, right? That's what bridges are all about. So that's my second favorite bridge. What about you, Kim?
I don't know. I never really put it that way. I don't really know. There are just so many bridges out there and so many different configurations, and it's just something I just love looking at and finding out about. So I don't really have a favorite second.
Well, and so we have some technical questions remaining. So this question's from Darwin. I noted the rather labor-intensive manual inspection process for the main cable. Have non-destructive inspection methods been approved for more coverage of the cable, while the intensive inspection is left for shorter or less frequent checks?
There's all kinds of ways that people have proposed to do some non-destructive testing, but it is not turned out to be very practical for the main cables, because you can't penetrate into the cable very well and know exactly what's going on in there. So this is the best way to actually tell exactly what's going on in there is to open it up and look with your eyes. That way you can quantify what's going on, and you can pull out pieces for testing and whatnot. So there's lots of different non-destructive ways to test steel, and maybe Amy, you get involved in some of that in your inspection of above water.
Yep, there's a lot of non-destructive testing, and we do dye penetrant tests, you know, to ascertain if there's a crack through the steel. You know, we use ultrasonic thickness gauges, of course, to measure section loss compared to the original section, to try to determine if a repair is appropriate. We do a lot of IR, thermography. I can't say the word, but I think I need a drink of water. Anyway, we have an IR camera. Actually, I was part of a research program with Cass Allborn and got really exposed to this innovation. And we invested in the resource because it's basically, you know, X-ray vision looking through a concrete bridge deck and being able to sense the heat, the poor concrete that's missing voids and delaminations shows up as bright red, whereas the sound concrete around it, you know, is a normal color. So there's a lot of different tools in the toolbox, so to speak. You just have to know the right one to use. And again, access a lot of times is a tremendous challenge. So especially with fracture critical bridges, which are your 2-stringer bridge elements, it gets to be pretty intensive, but at the same time, there's always a good tool in the toolbox.
All right, I'd like to change gears a second. I see a student, unless she's graduated, she's asking, were other locations ever considered for the placement of the Mackinac Bridge? And they point out to, and this is where I took German and I lived in Texas, and so my French is not so great. Bois Blanc.
Boise Blanc.
Thank you. I didn't know what to do with that, you know, in lawns. I didn't know how to say that for about the first 6 months I moved up here. So, but yeah, were there other places considered for the bridge?
Yeah, and you mentioned Bois Blanc Island.
Yeah.
That was a location for what was called the Fowler route. It actually went from Sheboygan across to Bois Blanc Island and over to Round Island, which is the little island with the lighthouse on it, and then to Mackinac Island, and then over to St. Ignace. And so that route actually had route surveys done on it, and you can find route markers along on Bois Blanc Island. Until they finally determined to put it right where it is now, the straight shot across the shortest area of the straits. So yeah, there were different routes. And that other route was going to be a series of causeways and smaller bridges and whatnot. I don't think there was a big suspension bridge planned for that route.
Okay.
No, and I think it would have taken a considerably more amount of time using that route to access it.
Yeah. And then Mackinac Island would have vehicles on it. So it shows you how different life could be if that were to have come true.
We have a question from one of our alumni who lives far away and crosses the Columbia River, Washington to Oregon. So he wants to know, what is the federal requirement for bridge underwater scouring and public disclosure? That bridge is well over 80 years old and experiences 2 million, I don't know what MMs is, of traffic grading, crack, weldment repair each year. $2 million, I think he means, of traffic grading, crack, weldment repair each year. So what is is this public knowledge, the results of the scouring tests and things like that?
I mean, it should be. If federal regulation requires routine inspection of a bridge every 24 months, once every 2 years. And for the underwater bridges, that's the question, I think, about the scouring. So underwater inspections are required by law once every 5 years. If a condition is discovered and it needs to be monitored more frequently, then as the dive team leader, you know, you make that adjustment and you start kind of amping up your inspection frequency to kind of monitor things, kind of babysit it to make sure it's safe. And then ultimately, if things aren't safe, it's your responsibility to close it. And it might be closing a lane. You know, we've closed probably 24 bridges in the last year, 2020 up until this year. I think we've only closed maybe one this year, but it happens. And that's that's why I started out saying, you know, you never have to worry about the safety of a bridge because qualified people are inspecting these. You know, they're getting a physical, a doctor's physical by qualified people. And if they're not safe, then they're going to be doing those emergency repairs, like those deck grading repairs that were mentioned. Or if there's a scour issue, then they're going to do, you know, some kind of remediation to address the scour and the undermining. Hope that answers
That's comforting.
that, okay?
That's really comforting to know.
Yeah.
No, thank you.
So a fun question, and I know about this, but have yet to participate. Is there likely to be a bridge walk again?
Oh, the question is there likely to be one again? Well, yes, for sure. There's
Yeah,
likely
for
to be
sure.
one again. And as of right now, the bridge walk is still scheduled. The only one that was canceled was 2020. So we're going to be looking closely at it as things open up. And who knows, if you have a crystal ball that is accurate, we'd love to hear about it. But we're just like everybody else trying to find out how we're going to go forward. But yeah, we're hoping we can do the bridge walk.
That's great. So when is the bridge walk for those who are listening and might want to participate this upcoming year?
Labor Day.
Labor Day.
So
Day.
yeah, it would be Labor Day. So
How long is it exactly?
well, our new technique is it can be as long as you want it to be, because you can start on one end and just go as far as you can, turn around and come back. And there are no buses, so you can go across and all the way back and do a double cross, what they call it, or you can go halfway and back, or quarter of the way, or you can just step foot on it and turn around and go away. So
Go buy your t-shirt, right? Just go buy your
Right.
t-shirt that I walked it.
whatever you want to do.
My first time, I was alone. I would have rather had been a passenger the first time going over the bridge, but I was alone and I was getting closer and closer. And I just had to tell myself to breathe. Just breathe, relax your fingers. You can do this. Just keep driving straight. But it was quite intimidating to that's the biggest bridge I think I've ever crossed.
Huh.
And I don't have fear of heights, but it was just so exposed, you know, it was tremendous. So one of the comments was, I hear you can pay somebody to drive you across the bridge.
You don't even have to pay, right, Kim?
Right, and it's free. And before
Yeah.
COVID, you know, we do that for free. You just call us up and say you'd like a driver, and we'll drive your vehicle across. And anything from a motorcycle to a semi truck, we have folks that can do that. But you know, we can't do it while we're social distancing, so we stopped that service and during COVID. And what we will do is, if you want, we'll drive either in front of or behind you with our truck, going with the light on, going as fast or slow as you want. Well, not as fast as you want, but as slow as you might need to, just to give you some security to get across. But we can't
And
get in your,
you can't ride on your bicycle across the bridge, right?
no. No.
But you can ask for help getting across the bridge.
Right, that's another service we had before COVID, is taking your bicycle across, and then you would go across inside the vehicle with us, and we would haul your bicycle on in the pickup truck. But we can't social distance and do that, so darn COVID is putting us out of those businesses.
So there's a funny comment from Hayden. Can I just read that one out loud?
Hayden.
He's a half-blood, or they're a half-blood Youper, and thus crossed the bridge lots as a kid going to visit family before their time at MTU. Henderson family tradition calls for you to pay for the car behind you at the toll booth and welcome them to the UP. I'd love to expand this tradition and maybe someday get my bridge crossing paid for. My grandpa also requires windows rolled down year-round while you're on the graded section. It sounds pretty cold and windy.
I love this person. This is great.
Yeah, as long as they're not sticking their head out the window.
Right.
But yeah, we do get a lot of people that pay it behind them, and so it's a nice treat for our patrons if somebody has already paid their toll. So it's a good deal.
Well, Hayden, thanks for joining us. He was a somewhat recent grad of the Civil and Environmental Engineering Department. So thanks for joining us. And Hayden, hopefully you can start that new tradition as folks listen tonight.
Has anyone here walked the bridge on Labor Day?
Mm-hmm.
Oh yeah,
Yeah.
yeah.
well, I shall have to add that. Audra, we're going to have to do this one of these days. Yeah.
But how
Yeah.
many times, Kim? Because Margaret and her husband have walked it 22 times. That's pretty impressive, I think.
Yeah.
That's
Got
good.
me beat for sure.
Mhm.
Amy, how many times have you walked it?
Twice. I'm so embarrassed, but only twice. My goal is to definitely walk it this year. And, you know, now that my kids are old enough, so I don't have to like carry them on my back or anything, we'll definitely be doing it as a family event.
So Kim, do you have any influence about the color of the bridge? Because we'd really like to see it painted gold and black.
No, there is no influence. And, you know, we've been doing these major painting projects since the mid-90s. So if we were to change the color, it would have taken us 25 years to change the color. So it's going to be foliage green and ivory towers for forever, I think.
Foliage green is the official color.
Foliage green, yeah, is the official color. Yeah.
And so someone asked if there was any credence to the rumor it was because of Michigan State. That's why it's
No, not at all. Not Michigan State. It was, yeah. No, didn't have anything to do with that. It was to be more aesthetically pleasing for the environment and yeah, nothing to do with university colors.
Well, we're coming up on 7:15, and so I'm going to pick one more question to get answered, and then maybe Audra can. And Audra, if we could then pass it to Kim and to Amy to make some closing remarks, I think that'd be great. And so for me, thank you everyone for joining us. This has been Michigan Tech Husky Bites, sponsored by the College of Engineering. This evening, we've been featuring civil and environmental engineering on International Women's Day, and it's been wonderful learning so much about the Mackinac Bridge. And so this is from Leonard. I think it's a question to Amy. Is there much zebra or kudra muscle built up on any of the piers?
Zebra. There are some zebra mussels, definitely. We've seen them on several structures, including the Mackinac Bridge. The kudra, I'm gonna have to get my little book, my marine biology book out to see what those ones are.
right. And really, this question is for both of you. Did you have to overcome a fear of heights for your job?
I didn't, Kim. I don't know about you, but I've always been kind of a little bit of a daredevil when it comes to heights or doing things like diving or climbing. You know, I like the view from above. I like different perspectives. So I like looking up from a low elevation, and I love looking down from something tall. So no, fortunately, I didn't have to practice that. It just was inherent.
Yeah, and I also do not have a fear of heights, but I'm a terrible climber. So I have a hard time climbing around, but put me in a bucket truck and I'll, you know, snooper truck, that's no problem at all. But I do have a little bit of claustrophobia. So I have a hard time in the tower. So I really have to talk myself into that, but, and it's getting harder and harder the older I get. So I'll admit that claustrophobia a bit.
Well,
I'll go in for you anytime, Kim. You just let me know.
All right.
well, I think any parting comments from either of you?
Well, I'd just like to say it's been loads of fun, and I was looking forward to doing this with Amy. I've known Amy for a long time, back when she used to work for MDOT, and so our paths have crossed in good ways throughout the years. So I knew this would be fun, and everything I do at Michigan Tech is always fun. So I really looked forward to it. It's been a nice evening, right, Amy?
Yes, absolutely. And just thank you for thinking of us. Like I said, anytime I get to spend time with Kim, I'm delighted. And, you know, Michigan Tech has been such a huge part of my success. It was the very best decision I ever made to attend Michigan Tech. It's completely, you know, opened up my world and, you know, made me realize my dreams. And, you know, I learned how to drink beer. There's so many positive things that I learned at Michigan Tech, but I really do credit the university for making me a good problem solver. So thank you. Thank you for your time, everyone.
Well, it's been an honor to spend the evening with you women. Very, very, very proud of your careers and of you as human beings. And thank you so much for supporting us. And thank you everyone for joining us. So tune in next week. We're going to hear about extracting metal from from stuff you can find in your own backyard. All right. So thank you so much, everyone. We're signing
Bye.
off.
Bye, everybody.
Good night.